Alright, welcome back to my 27th day of daily Leetcode commitment. As we wish from yesterday, today is a Leetcode program of total waviness of numbers in range 2. I just mentioned yesterday, we don't want to see that. Actually, we have solved this yesterday from the original problem, that how much we have done in here with the simple approach with the one helper method. But today is advanced version of it. So let's get through it. For those people who don't have knowledge from what was the problem that we solved yesterday, I'm going to run through the question again. We are given two integers, num1 and num2, representing an inclusive range, including num1 and num2. Let's say we are given from number 1 to 10. So we have to articulate these two numbers from 1 through 10. So the waviness of the number is defined as the total count of the peak and valleys. Okay, so a peak is a digit which is strictly greater than both of its immediate neighbor. A digit is a valley if it is strictly less than the both of its immediate neighbor. What does that mean? Okay, if we check, let's say we have a two number in here. Let's consider this is 3 and 3, and we have another one called 1. So this look like a twin tower or something, but let's say this is 3, and this look like a valley shape. So we can consider if the middle number is less than both left and right number of its neighbor, we can consider that is a valley. What about the peak? So the peak is a different story. So we have a middle number in here. It's like playing the Tetris. Middle number is slightly larger than whatever the situation it is. It is called peak. Maybe like this, or maybe the same number. So it is called peak. So the first and last digit of the number cannot be peak or valley. That also makes sense. So if you want to be the valley, it should not be at the either edge of the number. And any number fewer than 3 digits, let's say like this, have 0 waviness. So if we saw the valley or if we saw the peak, we can count that valley waviness is 1. If we don't see it, just 0. So we have to return the total sum of the waviness of all numbers in the range. So let's go through the example 1. We are given like 120 and 120 through 130. So if we check all these numbers in here, we have to check the middle number, and we have 3 numbers. One is 120, another is 121, the last one is 130. That's why we return the 3 in here. How about the example 2, 1982, 202? So the same here. So 1989 is greater than the left and right of the neighbor, and then in here the 20 are less than the left and right of the neighbor, which is creating the valley. So we have 2 valley and 1 peak, and then we return the 3 in example 2. How about the example 3? So for example 3, I have a preparation of the contest from yesterday. So we have to check the both number of the middle. Let's say we check like 484. So the 8 is greater than the either left and right. So this is considered the peak. What about we move to the second portion? 4 is smaller than left 8 and right 8, which is creating the valley. So we return the 2 in here. Alright, that's simply explain the dry run of the manual process or how the problem should work. And this is our solution yesterday. We just calculated it, but today I believe if we just copy and paste that one, it won't probably hit the time limit AC. But it will solve the given XML like 1 to 3, which is a tiny data set. I think the only change in here is you see the constraint from here. Before that is 100,000. Now it's, I don't know, like 10 power 15, which is really huge number. As we expected, we are hitting the time limit AC. So what I can think of it is, how about we create the memoization on top of our solution yesterday, and skipping the leading 0, like in case we could have some leading number at the front or at the end. So I'm gonna get rid of this method, and let's check how do we handle the digit yesterday. So this approach is also good, but how about we make things called digits of num, which is the integer that will return the integer, and that is going to be the digits array. We want to convert the given integers into each digit array. Let's go in and let me make the parameter to non-constant so that we could change it through, and the only idea I can come through is that num is greater than 0. I'm gonna append the digits by doing the modulo of 10, and I will update the num by dividing with 10. Before that, I'm gonna return the digits. Maybe let's check through our numbers. I was currently return the 0 at the moment, and then let's do like print of digits of num1 and num2, and we don't need that waviness anymore. So this is just to test out our helper digit function, it is working properly or not. So we have to use a standard variable in here. Cool. So if we put the 120, we got like 0 to 1. I think we need to do the reverse in here. Alright, cool. So we got what we need, and I am going to, okay, cool. I'm going to use another helper function called maybe solve with the name of integer, and which is going to return the how many waviness we could get by computing the numbers. And yeah, and we want to check like the number is okay. Okay, let's use the digits method in here, which is going to call the digits of num, and we need to do the memoization in here. Now we need to consider what is the great data structure for us to create the keys for us. Let's go like memoization. I cannot think of anything now. Maybe just create the make key function, which is going to help us create the key for our input values. Maybe take the position, which is the index, and second last digit. Yeah, because we need to consider the last digits in here also, and last digit. Right, but we are expecting to have like minimum of 3 digit, but if not 3 digit, maybe we need to consider the different thing. I will return the integer in here. Let's do like second last digit. I'm gonna increment the second last digit by 1. The same for the last digit. And we'll return with the position. Maybe we do need to multiply with 11 so that we could have a better. Okay, the idea here is we have a number 1, so we multiply with 11, which is begin the 11. How about number 3, which is going to be 33, and then I'm gonna put the second last digit in here and multiplying with 11 again with the last digit. Hope that makes sense. Yeah, let's double check what I'm doing here. Oh, okay. And maybe we will use a key is an integer and the value will be the count. I'm going to use the double in here and sum of in. Alright, cool. So after we have this making the key, what we need will be do the default search of our case. Let's go DFS, and I will just use the same as position, which is going to be the index, and type how close is the two number, and started, which is going to be the boolean. So we need to keep track of the default search location that we are at the beginning or at the end, and then same as this two. We need like second last digit and last digit, and what we are going to return is values of our tuple. And there we go. Okay, I always make a mistake in here. Okay, we need to make sure that position we are having is always greater than our digit count. If not, we return the default value 10. Alright, that makes sense. And now we're going to use our helper method called key to create the make key, which will pass the position, second last digit, and last digit. Maybe this is too over exaggerated for the method. Okay, cool. And then we going to check if not tied between these number. What we want to do is we will also check if it is in the cache. So how do we know it is in the cache? By checking the memo with key. So we just repopulate it, and then if it is already in the cache, just return it. So this is where the exact cache came in. And then we also need to do the limit of our numbers. So limit is to check if its type is true, we're going to return the digit of the position. If not, just return 9. Yep, okay. So next is we need to keep track of the total count and make it 0 originally, which is going to be the real function that we are going to use. And total sum is also 0. So I'm going to go through the digit using the limit. So the reason why we have a digit position is I want to go through from 0 to how many digits we have till the end. By doing that, we can do the next type with the type and maybe check which digit is the existing digit we have or not by using the position index. And we need to think about leading the 0. Maybe let's start do in here. If it is not at the started and digit is equal to 0, we will record the child with the default search of the branch by incrementing the position and next type, and starter will be false because it's already the nested, and then second last digits will be -1 and -1. Cool. And if it is done, what we can do is we can increment our total count with a plus equal to 1, which is to calculate whether values or whether the peak. And same for the total sum will be 1. Instead of that, I think making the child.count sum much more makes sense. Yep, this should be the child.count, and we will continue our method. Cool. So this is a little bit complicated to explain now because of I did over engineer it and we will calculate we have extra width across the problem. What I mean by extra width is we have a case like maybe like duplication of these two number again. There we go. And like this. So that means we have an extra width like 1, 2 in here. So we do need to measure like, do we really want to count these numbers or not? By using the next second last digit, which is going to be integer, and next last digit. Now, I don't know. I cannot think of any better variable naming from now on, which is going to be the repeated process. Started with the resetting the next second last digit to -1. Next last digit will be the digit. If not, we will check like second last digit is equal to -1. The reason why we need to check is we are passing the -1 in here. And yeah, so we can just, if it is -1, we can just replace our second last digit with the last digit, and next last digit will be the digit. And just call the else for our real checking of peak or valley. Let's call it peak, which is going to be the second last digit, which is the middle one we expect here, and it's greater than less than the last digit, and last digit is greater than digit. So that's technically mean it is a peak. And another is valley, which is going to be the reverse of this. I will just replace it and like this. Right, if it's peak or is valley, we will do the extra wave to 1, which is a variable that we declared above. And then, as always, we need to repeat this process. Cool. Do we still need to call the child in here? Yep, exactly. So let's record the child in here after we have done all through the conditioning. Position should be the +1, next start, and this is going to be the start again because we are starting another branch of depth research, and we're going to pass the next second last digit and next last digit. After that, we can update our total count with the child count, and so child we got the total count from the depth research of the tuple, and sum is from here. So total sum will be child of sum and child dot count into extra wave, so we don't need to recalculate again and again. So that's for our for loop, which is a little bit huge function, I would say. And then we can do the reset, which is going to be the total count and total sum, which is we need to return for our depth research function, and just return the result in here. Alright, cool. If everything went well, what do I need to do? Yeah, let me check. Alright, there is a depth research, but we still need to call that depth research below our real depth research. Oh wait, I think I forgot to check the reset is already in the memory or not. Let's go like if type, then we can check like if our key is already in the memory, and then we can keep it. Cool. So we got what we need for our depth research. And last but not least, just call the depth research with the original position of 0. If type is true, because it's at the beginning, and status is false, -1 and -1 dot sum. Alright, we just need to call in here. Let's use the solve with the num2 minus solve of num1. Let's try to do the dry run first. Alright, as always, have an issue with this. Alright, what do we do? The mistake again. What did I do wrong in the next stake? It should be the easiest one instead of for loop. Let me check. Next stake integer cannot be referred. Oh, That's a Boolean condition. Alright, cool, let's try to submit. Okay, actually that is a little bit complicated for my solution, I guess. Maybe I was wondering if I could write in the scripting language like Python or JavaScript. I think I should have a better explanation. So the main idea in here is I just want to keep the process that I have done in this area, like left and right, so we can combine it back and then we return the total result. So if I have to, I don't even know what is the time and space complexity technically, because it's so much complicated. I think it's d into 10 power 2 because we use the digit into multiplying with the 211 in here. Yep, that's what we expected, and I believe you guys will enjoy this video, and sorry about that, and I wish I can deliver the better explanation in the future, and then see you in the next one. Bye.